Hi, everybody. Today we're going to look at our first lesson in our very last unit for the year. So that's exciting. This unit's all about systems of equations. Just a reminder, when you're trying to write on these, for those of you that are using Kami to take notes and do the practice, if you use two fingers and drag them apart, you can zoom in so it's easier to write. And then when you zoom back out, it'll be a better size. If you try to write on it like this, it can be a little bit tricky. So just something to think about. I'm going to zoom in just a bit here so I can write easier as well. All right, so this whole unit is on solving systems of equations. All right, and so let's talk about some of these terms that you're going to hear. So systems of equations, basically are just two or more equations with two or more variables. All right, and a solution, all right, there's that word solution, you'll hear that quite a bit, is basically the point or points where the equations intersect. So if you're looking at if you draw two lines, this point right here where they cross is your answer. And just remember, every single point has an x value and a y value. So there's three ways to solve them, and that's what this whole unit's about. The first way we're going to look at today is graphically. So that means using a graph. So we're going to graph both on the grid together and see where the point is that they cross. The other two ways to solve this is algebraically, so using algebra and equations, and we'll talk about those in the next couple weeks here. Just a reminder, we only have 13 instructional days left, so we're getting down there. Like I said, this is our very last unit, and it's an important one. You're going to use these skills next year in geometry and then again in algebra too, so it's important that we get this down. And I like that we're doing this last because it's a good review with solving equations and finding slope and y-intercept and things like that. Okay. So just remember, when you go to graph, you want to make it so it says y equals. We want it in this form, y equals mx plus b, where m is the slope and b is your y-intercept, which is also where you start. Your other option is to get it equal to y and then go to your table of values in the calculator, which is nice because you can see them. We'll look at both. All right, so this one, it already says y equals, so my slope is -1. My y-intercept, which is where we'll start, is 6. All right, so we start at 6 on the y-axis. And then since our slope's negative, that means we're going to go down 1 over 1. Okay, if it's not a fraction, just put it over 1, because -1 divided by 1 is still -1. So from here, we're going to go down 1 over 1, and you always go to the right. The more points you put on, the better with these, because you really want these graphs to be accurate. Otherwise, you might have the wrong point. Okay, you can follow that same path and work backwards. Go up 1 and backwards 1. All right. Now, again, these are called graphing calculators for a reason. They're meant to help you graph. So if it starts with this negative, make sure you're typing in negative and then x plus 6. It's always good to check. Yeah, that looks like my graph, following the same pattern. Second graph, look at -2, 8. There's that point. 0, 6, 1, 5. All those points are right on there, so you know you did it correctly. Okay, so now you're going to want to draw that line. Okay, so if you would like to draw a line easily instead of trying to draw it by hand on this, I know it's hard. If you're, at home or doing this on paper, then you can just use a ruler or a straight edge. If you're using Kami, if you go to the shapes right here, insert line, start at a point, pretty far up the graph. That's why I like to put as many points as possible, and then just click and hold it down until you get to the end. Okay, so there's our line. I'm going to go back and finish it up here. So we want to put the arrows to show that it's going to continue forever. And the equation, I'm going to put it off to the side since we're going to have another line over top of it. Okay, so now we're good with that equation. Let's take a look at the second equation. This one, unfortunately, doesn't say y equals. So we need to get it into this form first, right here. So the first thing that we're going to do, if we're trying to get y by itself, it's helpful to circle the y, the term, including the sign in front of it. So then you can see, oh, that 3x has to go. It's positive, so I'm going to subtract it. So I'm left with 4y equals, and it's not 13x, all right? Remember slope and y-intercept up here. You want to put the x term first where your slope is, and then the number by itself. So I'm going to put the negative 3x and then the positive 16. All right, y is not completely by itself. Now we got to divide everything by 4. So we're left with y equals. I can't divide that evenly, so I'm going to just leave it as negative 3/4 x. And then 16 divided by 4 is 4. So there's our equation we're working with. Remember, you can go right to the calculator at this point and get your points. I like to use slope y-intercept, but I like to check in this. And I'm going to put it in y2 so I can see the whole graph together. So the fraction, you can either hit negative first or put it on the top, but it doesn't matter. Alpha y equals, enter, 3/4, and then hit the right arrow button and put the x after, just like it's shown here. You could also put it up top with the 3, but don't put it underneath. All right, plus 4. Take a look at the graph. All right, so they're going to intersect about there. Now, if you want the actual points, we're now looking at the red points over here. So negative 4, 7, 0, 4. You can scroll down. Don't worry about the fractions. 4, 1. All right. You can also say, well, my y-intercept is 4, which again is where we start. And look at 0, 4 in your calculator, same point. All right, and then our slope is negative 3/4, so that means we're going to go down 3 and over 4 to the right. So from here, we're going to go down, oops, ignore that line, down 3/4. Down 3/4. Oh, there's the point that they have in common. All right. I'm going to go up 3 and backwards 4 just to get a couple more points on there. The more points you have, the more accurate your graph is. All right, and then I'm going to go and grab my line. I'm going to make this line a different color so it's easier to see. And we'll extend it all the way through. All right, so now we'll go back. Got our arrows for this line and our equation. All right. Now, the point, it says, at what point did the lines intersect? It's right there. It's always good to circle it. And it's the point, remember it's xy, so it's 8, negative 2. A nice thing about the calculator, if you go down, if you aren't sure what the point is, see how these both have a negative 2? That means 8, negative 2 falls on the first line, and 8, negative 2 falls on the second line. So the point is 8, negative 2. And make sure it goes in parentheses. All right, there's one more thing I'm adding into this particular question, and that's checking to make sure that that really is the solution to the system. So again, this is another name, the point where they cross is another name for solution. All right, so if you want to basically show that it's a solution to the system, you want to take the two original equations. It's got to be the originals. So y equals negative x plus 6. And then the other original equation, 3x plus 4y equals 16. So basically what we're doing is we're checking to see if this really is the solution. So this is your x, this is your y. Wherever you see an x, you're going to put 8. Wherever you see y, you're going to put -2. So instead of y equals, -2 equals. Instead of -x, we're going to write -8 plus 6. Now this side's already simplified. If we get -2 over here, that means that we did it correctly. It's on the line. -8 plus 6 is -2. All right. If the point doesn't check in one of the equations, it's not a solution. So maybe you could have added wrong or subtracted wrong when solving. So it's always important to check. All right, so 3 times x we just said was 8. Plus 4 times y, 4 times -2. All right, 24 minus 16, or 24 minus 8 is 16. If you're not sure, type the whole thing in. Second quit will get you back to the main screen. 3 times 8 plus 4 times -2, 16. Since you got 16 on both sides, it checks. So yes, it's a solution. Okay? All right, the other part of this chapter, this lesson, how many solutions? All right, so this first one has one solution, and it's right here. This one does not have any because you're dealing with parallel lines. All right, and the reason we know that, they both have a slope of 2. You'll talk more about that in geometry next year. This one has infinite solutions. That means that there's so many you can't even count. Because it's the same line. They're called coinciding. Sometimes what will happen is they'll give you the equation in y equals mx plus b form. Then they might give you one where you have to solve for y, and it ends up being the same exact line graphed right over top of it. So basically every single point on those lines is an answer. So there's infinite solutions. This one you might not see right away because we don't see the intersection point, but with the pattern that these lines have, they're eventually going to cross, and they would cross one time. On this graph, I threw a couple in with a quadratic as well. They're never going to cross, right? Because this one goes back up and it's increasing at a faster rate than the line, so there would be no solution with that one. And then on this one, you'd have 2 solutions. It would be the point 0, -3, and it looks like 4, 5. All right. So what I want you to do, try this next one, and I will go over it in the next video.